In this video, we will design and implement our first state machine that will perform similar to the circuit you see. We have two LED lights, and at every second, the light that is on is switching between the red and the blue LEDs. Now, before we design the state machine together, I would like you to pause the video and draw a state machine diagram that represents this program by yourself. Then you can confirm your design with the design we will do together. So to design our state machine, first we will start by drawing a circle for every state. The blue state basically has the blue LED on and the red LED off, and the red state has the red LED on and the blue LED off. We will also define two variables. The first one is the time since the last switch happened. We will call this TLS. Basically, every time we switch states, we are going to save the time in that variable. And the second variable is the period, which is the time we are specifying to blink the LEDs. In our case, it is 1 second. Now, the event that can happen to take us from one state to the other is simply if the time right now is more than or equal to the time since the last time we did the switch, plus the period we specified. So if the last time we did the switch was, for example, at 10 seconds, and the time right now is 10.5, then we do not make a switch. But if the time right now is 11, then we do make a switch. And this transition can be represented by these two arrows. In our case, the event to switch from red to blue and blue to red is the same, which is 1 second. However, each transition can have completely different event. For example, transition from blue to red will happen after 1 second, but transition from red to blue will only happen when a button is pressed. Now we will start building our circuit. I am using something called Tinkercad, which you can access by tinkercad.com, and you can create your free account. This is a way to build your circuits and have fun and simulate your code without actually working with real hardware in case you don't have them. But in my case, I'm just showing it for easily showing you everything I'm doing. So first I'm selecting that I want to work with circuits, and I will create a new circuit. Now, the very first thing I will add is the Arduino, obviously. And I will also add a breadboard. So we need first two LED lights. The first one is going to be red and the second one is going to be blue. Now for every LED light, we need to add a resistor. The reason we add a resistor is because the voltage coming out of the Arduino is 5 volts and the LED takes less voltage than that. So by adding a resistor, we're basically reducing the voltage that is taken by the LED. So we're going to add a resistor from the negative pin to the ground, and this resistor will be 220 ohms. We will add a similar resistor for the red pin, also 220 ohms. Now the next thing we will do is that we will connect these pins for every LED to one of our digital pins on the Arduino. I will use pins 10 and 11. So for the blue one, I'm going to connect it to pin 10, and for the red one, I will connect it to pin 11. Now in this case, it doesn't matter which pin you use, obviously, but if you want to follow the same code I will have, make sure to connect the blue one to the 10 and the red one to the 11. Now we also need to connect the ground to our ground from the board. We can change the colors of these wires if you want to make your diagram more neat. Black is usually used for ground, red is usually used for power. In this case we will make this blue, and we will make this red, although I just said it's usually used for power, but in this case it will reflect our LED light. So now that we have our circuit, we can actually start building our implementation for the state machine. So I'm going to press on this code here, and we're going to change from blocks to text. So as you should already know, every Arduino program should have two functions, the setup function and the loop function. The setup is called first at once, and then the loop will keep on looping. So the very first thing I will do is by deleting the existing sample code. Now we will first start doing some definitions. The first define we will do is the LED pins on the Arduino. So I will call this LED pin blue, which we specified at 10. And the second define will be LED pin red, which we defined at 11, or we connected to the pin 11. Now in the setup, the very first thing you do is that you specify the mode of every pin, whether it's an input or an output. In our case, it's an output. We want to output voltage to these LEDs to light them up. So we will use the function pin mode, and we will specify the first pin blue, and we will say this is an output pin, and then we will do the same thing for the red pin. Now before we start building our state machine, I just want to test that our wiring is correct. It's important to test things at an early stage before you move on, just to make sure you don't have problems. So I will simply just turn on both LEDs. We will use a function called digital write, and we will pass the pin number, which is represented by our definitions, and we will say it is high, and we will do the same thing for the red one. And we can start the simulation and see what happens. Okay, so perfect. They plugged the USB in, and both our LEDs are turned on. So our connection is working. So now we can start building our state machine. I'm going to stop the simulation. Now, a very easy way to implement a state machine, especially in a program like this, is by writing a function for every transition that can happen. So for every state, when you're going to transition to that state, what is going to happen? So in our case, we can have a function called transition to blue state. And we can have another function called transition to red state. So in here we will define every little thing that will happen whenever we transition to the blue state, and every little thing that will happen when we transition to the red state. And then inside our logic in the loop, whenever we want to transition, we will just call these functions. Now another thing that we should do is that we should define our states, be able to represent our states as numbers. So the first definition I will do is state red, and we will give it a number 1, and the second definition is state blue, and we will give it number 2. So in this case, whenever we use state underscore red, it will actually replace it with the value 1. But for us as humans, we can read state red, which will make much more sense. Now, another thing we need to keep track of is which state we are in right now. This is a very important thing to keep track of, because at every iteration, whenever we want to do a transition, we need to know where we are to know where we're going to move to. So we're going to save that inside a variable called state. And we're going to initialize it by saying that we are in the red state. Now, if you remember from our state machine diagram, we defined 2 variables that we're going to use to check whether we can do the transition or not. The first one was the time that last time we did a switch. So we're going to use unsigned long as the type of this time, and we're going to call it t underscore last switch. And we're going to initialize this value inside the setup function at the end to the time right now. So we're assuming that the moment the setup ends and we start the loop, this is when the last switch happened. This is for the very first time. To get the time, we will use a function called millisecond, without the second at the end, just s. Now this function will return the value in milliseconds. So the second variable we will define is our period. And in this case, it's 1 second, but because we're dealing with milliseconds, it's going to be 1000. So that's 1000 milliseconds, which is equal to 1 second. So now we have our variables. We initialize the time at the very beginning. We initialize the outputs. We're going to remove these digital write high when we first start the program. This was used only for testing. And now we are ready to start defining what will happen every time we do a transition. So whenever we do a transition to the blue state, we will write high to the pin of the blue LED, and we will write low to the pin of the red LED. We need to make sure we switch the red one off and we turn the blue one on. Another thing we're going to do at the end of every transition is to save the new time. Because in here, in t underscore last underscore switch, we're basically saving the time of the last time we did a switch. So every time we do a transition, we're going to save the time again. I'm just going to copy paste this line. And another thing we're going to do as well is to change which state we are in right now. This is also very important because this is what we are using to keep track of where we are. So in here, we're going to do state is equal. In here, we are doing a transition to blue state. So now the state is equal to the blue state. Now we will apply a similar thing to the transition to red state. First, we will write to the red pin high, and then we will write to the blue pin low. We will also save which state we are in right now, which is red. That's when we transition to the red state. And we will save the time right now inside the T last switch. Okay, so we are ready basically to write the logic for our state machine. And this will happen inside the loop. This is where our program is being called every single time. forever, basically, as long as our Arduino is on. So to start with, we're going to use something called switch. Now this switch, if you're not familiar with switch is very similar to doing if this is equal to this, and if this is equal to this, and so on. But instead of doing if else, if else, if else, we're going to switch the value state. This is our variable state that defines which state we are in. And then we will do cases. So we defined our states as state underscore red and state underscore blue. So the cases we can have here in state is state underscore red and state underscore blue. Now it is very important at the end of every case to use break, because otherwise it will just keep on going. So now what does that mean? So every time it will check which state are we in. That's the switch part. And if it finds out that it is in the red state, it will be executing whatever code we write here. If it finds out that it is in the blue state, it will execute whatever code it finds here. So what do we want to do if we are in the blue state? Sorry, in the red state. Basically, we want to do transition to blue state. This is the function we defined before. But do we want to do it every single time? We need to check first if we can actually do the transition. We had that condition saying if the time now, so we will get the time now by calling the millisecond function, if the time now is greater or equal to the last time we did a switch plus the period, then we can do the transition. And if the time is not satisfied, if our condition is not satisfied, nothing will happen. We will break and then it will continue looping until this transition condition is satisfied. That's the only time we will actually make the transition. Now we will do the same thing for the blue state. If we are in the blue state, we need to do the same check first. And then we can do transition to the red state. And this simply defines our state machine. It is very simple when you start dividing the state machine into smaller functions and then dealing with just the logic of where are we? This is the first step. It wants to find where are we? Are we in the red or are we in the blue right now? And then we check, is the condition satisfied to make a transition? If it is, we do a transition. If it is not, we don't do anything and we keep on going. Now we're going to test this and hopefully it's going to work. Okay, so let's simulate this code on our circuit and see how it behaves. Well, it's working as we expect. It's switching the light at every second. I hope you enjoyed this video, and for practice, maybe link 4 LEDs or 5 and try to have a pattern of going from left to right and right to left. Start by drawing a state machine and then implement your diagram in a very similar way to what we did right now.